Yeah, I wanted to talk a little about synchronous programming in Python and how you can live backwards and remember the events of the future. But first, let's look at this quote from Through the Looking Glass of Lewis Carroll, which he wrote in 1871. In this, here Alice is astonished at ability of the White Queen to live backwards and remember what hasn't yet happened, and how she can react to the things that are only going to happen in the future. And because Alice only can remember what already has happened, but the queen's memory can work both ways. And this is one of the greatest paradoxes of Lewis Carroll, and I think it can be applied to software development, and in particular to the asynchronous programming, and most of all to the psychology of asynchronous programming. What is software development is not a constant fighting against complexity, and it is already challenging even when we know exactly what happens in our code, because what we try to do, we try to fit the real world, which is quite chaotic and complex, into the clear structure, simplified classification, and the events on the real world will usually try to put in a simplified, streamlined timeline, because usually in the code, one instruction goes after another, and we know that we can have the result of the previous instructions on the current line. But what if that timeline breaks? What if we need to deal with the results of the events in the code, which will happen in the future? Let's look at another quote. Here, there is the king's messenger, and he's already in prison, and he's being punished for the crime. He hasn't committed yet, and the trial will only begin next Wednesday, but he's already been punished. And so you can understand the confusion, and the thing is that we already deal with the events, with the result of the event, which is dependent on the event which will only happen, or it cannot happen. So let's try to code this nonsense in Python. Here's the code. So we have the king's messenger, and he has a flag which indicates if he has or has not an alibi. He's guilty by default because, well, the world of the True Looking Glass is a medieval monarchy, so he's guilty by default. We have the commit and crime or not function, which is the kind of which does say some processing, and as a result of this processing, has an alibi will be set to true or false. And then we have do trial function, which does some processing and gives us a verdict if he's guilty or not. And if he is guilty, we send him to prison. And it goes well, and it's pretty simple code when we consider it in the timeline, because each line only gets executed after that the previous line is finished. So we have the perfect timeline. But for example, let's say commit crime or not does some very long processing. For example, and it's dependent on the third party something. For example, it does a database request or request to some API or something else, and it takes a lot of time to process. So we might want to do that asynchronously in parallel. And eliminate this bottleneck in the program. And the do trial also can be parallel. So using asynchronous framework called Twisted, we can do that in a separate thread, for example, because the deferred thread will run the given function in a thread asynchronously and return immediately. We don't, so not waiting for this process to finish. So in this code, there is a problem. And the problem is, the problem just become a lot faster, but there is a problem. Commit crime or not sets the has an overbite flag, but what if there is a race condition? It doesn't set it right in time for the trial to assess this evidence. And the verdict can be given before the crime has happened. And if let's say the do trial can only is asynchronous, the guy can go to prison before the trial and before the crime happened. So exactly as the White Queen said. So we can demonstrate this. What can we do about that? Yeah, we can use a concept called a future. That's what the deferred to threads actually returns. The future is a concept which has many names in frameworks like Asyncio and Tornado. It's called future, and Scala, I think, as well. It is a future. In Twisted, it has its own quirky name called deferred. In JavaScript, it's often called promise. What it represents, instead of the actual result, it is a kind of what we have in return from the asynchronous function instead of the result. It's a kind of a future result. And what can we do with that? We can check if the result is ready or still pending. Checking this in the loop, we can actually wait for the result to happen, to block the code and wait. But when the result is ready, we can get the actual result. But most importantly, we can attach a callback to that object, and that callback will be fired up whenever the result is ready. So we can use that in this way. So here, the deferred thread returns the deferred object, and we attach callback, which is called first callback, to that deferred object. So the first callback is run when the result is ready. So we can run do trial whenever we get the result of commit crime or not. So from this, we get another deferred because do trial is also asynchronous, and we attach another callback, which is called second callback, and the second callback gets the result of the second asynchronous function, and then we can process the result of the trial. So in this case, the king's messenger gets the failed trial. Whenever he commits crime or not, he only goes to prison even in the case he actually committed the crime. So, but it now works, but it doesn't look very maintainable and readable, because we call callback from another callback, and it's basically a callback hell to which we descend. And but note how we write the code for the future first, and then we write the main program. That's how we start living backwards, because we need to think about what will happen in the future first before we start looking at the present. And that requires a mind shift, which we will talk about later. So how can we do anything about the callback hell? Twisted as a framework has its own, yeah. I like how it's represented by a snake pit. So true. Twisted has its own tools to avoid callbacks called from other callbacks with using the thing as a Python generators, Python coroutines. It has a decorated called inline callbacks, which makes code looks synchronous when it's still asynchronous. But Twisted, even if the Twisted was innovative and nice in 2002 when it first was released 16 years ago, but now it's rather old. It was one of the first popular asynchronous frameworks in Python, but now we have better things. And yeah, but Twisted still introduced some of the concepts we're still using today when we deal with asynchronous programming, such as a future, which is in Twisted called deferred, such as an event loop, which in Twisted called React. They have names for everything. But today, we'd rather use the framework called Asyncio, which is now, since Python 3.4, is built into the language. It has its own built-in library. It has its own dedicated keywords, async and await, and some others. It also uses event loops, which we'll talk about later. It uses future objects, and it uses async and await concept. So using Asyncio, our code would look like that. In this code, we just add the async keyword to our functions, and with this, we make them asynchronous. So now they run asynchronously, and they will return future objects instead of the actual result. So, await keyword makes the code makes such a thing that the next line doesn't get executed until the commit crime or not is finished. But it doesn't actually wait for it, because otherwise it would be a blocking code. But the code doesn't stop. It just switching context away from this place in the code to another code, which is waiting. It's kind of a waiting in line. and it's still working and processing other code. But when the result of commit requirement node is ready, it switches back to this place and proceeds to the next line. And with that, it looks like synchronous code, which is in fact asynchronous. It is all possible with the event loop working behind the scenes. The event loop is the thing which does the context switching. It switches back and forth. It is very useful, especially for when you need to wait for something, for some input or output, and it is usually based internally on the OS tools provided by the OS. For example, in Linux, it is based on the EPO by default. In Python, you can have different implementations, but for example, let's say by default on Linux, it uses EPO, which is a library that provides you asynchronous descriptors. You can write to a file or read from a file, or as in Linux, everything is a file. It can be a socket which connects to the third-party API or a database which is connected over the network. So you can write to the socket, and as the database needs time to process your request, you don't have to wait for the response. You attach a callback, similarly to the deferred feature, to that descriptor. And this callback is called by the operating system when the database starts writing to that descriptor back to you, when it is ready. So the event loop, when it comes across the asynchronous output, for example, it switches the context to other parts of the application which we can execute. And then when it gets the callback from the operating system, it switches back to the code where we have our await keyword, and it goes straight after that. And that switching is possible by using Python's generators and coroutines. It's quite useful. The most common application of that is web application, because in web application we need to process multiple requests from clients at the same time, simultaneously. And if we just run the application single-threaded, when it does processing of a request, it blocks. It can't do anything else until it finishes the processing the request. And if it's really dependent on the database, it waits for the response from it, and it stacks. That can happen if you find, for example, if you write your Flask application and you run it on a debug server, it will just stack every time. So it's not usable for, not fit for production in this case. So traditional approach is, and I think Apache Web Service still works like that. It just creates a new thread for each request, which gets all basically the copy of the application or copy of the memory and things, and it runs in parallel. But every thread just waits for all the input and output, and it is each thread is synchronous. And it works, but creating a thread on an operation system has an overhead all the time. It gets quite a lot of resources, and if you have to process lots of simultaneous requests, as in the case of the web application. You can run out of resources. You can only create a certain amount of threads. So asynchronous approach is to use the same thread, but every time you need to wait for some input-output, you just switch the context and handle the next request from next user. And when it needs to wait, you process the next request and next and next. And when the result is ready, the event loop makes sure the context switched back to this part of the code. So this line of parallel execution. So it's always switching back and forth. It's not the very best representation, but I hope it makes sense. So in terms of web requests, using asynchronous approach, you can process much more simultaneous requests from clients with much less resources spent. So in terms of the web applications, there is a few popular web frameworks for asynchronous programming in Python, which, for example, IOHTTP, which I quite like but never used on production yet. It is a web framework based on Asyncio. And it uses all those modern things like async await and stuff, which is now a part of Python language itself. The second one would be Tornado, which is more older alternative, and it switched to using Asyncio as far as I know now, but it used to have its own implementation of everything, of event loops and features and other stuff. And we have Twisted, which is not going to change because it's big, old, and but it's still relevant because it's networking framework more than web framework, but you still can use it. But remember about snake pit. So, if asynchronous framework give you performance advantage, why not everyone is using them? The main downside is the adding complexity, because once you start using asynchronous approach, all your code should be asynchronous, because you can't afford to have a blocking code in your application, because if you have the blocking code, it just stops your whole application, because you're still running this single-threaded application. And if it's blocking, it will, for example, you just forgot to add a await or async keyword. So you introduce a blocking code, and the blocking code will stop the whole your server, for example. And it will basically undo all your performance gain. So that's the second one. You need to keep asynchronicity in mind all the time, because it's very easy to forget something and introduce the blocking code, and sometimes it's really hard to find where it is. And so to avoid it, you need to live backwards in some sense, because you need to think about how your events are processed in terms of event loop, because you can't assume now that they are executed in the straight timeline. And it is quite difficult, at least it has been quite difficult for me, and because to switch the mind, to get your hand around that kind of timelines, broken timelines. And I think why it happens is because how our mind works. And Carl Jung, the famous psychologist, in 1951 introduced a concept called synchronicity. And actually, if you remember the first quote about the memory that works both ways, he liked to use that quote as an example to illustrate that concept. Synchronicity, among other things, it explores how our mind contemplates the events in the world, because we can't afford to think about how events are connected all the time, because we have subconscious understanding of how everything is connected, how one event is bound to another event, how they connect to each other, and how a result of one event causes another event. We do that subconsciously, and it goes to such an extent that sometimes we see patterns in the world where they don't actually exist. Like when you look at the clock and you always see 11:11 or 12:12. You think there is a logic behind that. Or you walk in the street and suddenly you see someone's talking about events or about something you have been thinking yourself in your own life. Conspiracy theories can be caused by synchronicity, because you like subconsciously we tend to leave it to our subconscious to know how events are connected. And asynchronous programming basically breaks that subconscious understanding of how events are connected in our code. And it can be hard to switch your mind. You need that mind shift to start understanding how the asynchronous code works. And this asynchronous thing can look overly complex now, and it can look over-engineered, but I believe you still need to learn that. And you need to train your memory work both ways, because it'll give you an advantage in your career, as I think. Because asynchronous programming gaining popularity in recent years, especially because everything is asynchronous now, suddenly. Because much of the software development is switching to web service, to the cloud, to microservice architecture, because microservices usually they tend to communicate in an asynchronous way, and asynchronous programming really helps. JavaScript is asynchronous by its nature. Web scrapers, they should be asynchronous to not be really slow, because, for example, popular web scraper framework of Scrapy in Python, it's based on Twisted, basically. So it is asynchronous. And there's many more applications of that. But I think if you train to think in that way, it will be easier to take up asynchronous programming, and it will be beneficial for a career. So, as the White Queen said, you have to run as fast as you can just to stay in place. And to go anywhere, you have to run twice as fast as that. That's all. Thanks. Thank you.
Hey, thanks, Mikhail. We have time for a couple of questions if anyone has a question. Great.
Thanks for your talk. In your experience, is there any tooling or techniques available to help you identify when segments of your code might be unintentionally synchronous? Because it seems like the synchronicity is something that we should be able to track at almost at an IDE level, rather than have an accidental library call turn out to be synchronous and ruin everything. It would be really nice if that was exposed somehow. I'm not sure if you've seen that happen.
To be honest, I'm not aware of such tools. You can try to profile your application and see if it stacks anywhere. But it is challenging. I can't tell anything from the top of my head, sorry.
I think there's an environment variable you can set that produces output from Python when async functions are not done correctly. I can't remember the name of it, but there is an environment variable you can set. I think it's used in Django channels and things. So that would answer that question.
Mm-hmm. Oh, that's great. Yeah. Thank you.
Hi. In the context of reactive or X extensions and that, you know, in terms of approaching asynchronous problems, would you rate the reactive way of doing things using RX libraries and that kind of thing? If you're familiar with RX libraries.
How can I rate it?
Yeah, well, like, would you recommend it? You know, like, I suppose it's an additional abstraction that you can use on top of async.io, you know, to create a reactive way of dealing with streams of data, and I suppose it takes away some of the challenges around concurrency, because you're not really, as long as you keep within, I suppose, the RX way of doing things, you know it's going to be thread safe and whatever.
Yeah, to be honest, I don't have much experience with that. I think it depends on what you're working on. If it's a web application, which I have much of experiences, so you don't really need to do that, because the logic more attached to a request than to a pipeline, which usually reacts to events. But it can be beneficial, yeah, I'm sure, but in certain cases.
Great. If there's no other questions, we'll leave it there. There's a break now until 11:30. So thanks one more time to Mikhail. Please show appreciation.
Thank you.